Greetings and welcome, internet friends. Mr. Waddy here, talking about Algebra 2, Chapter 10, Section 3, two-way tables and probability. I'm going to start today with an exploration problem. I think these connections will be quite helpful for us in understanding how to generate these tables as well as how to read them. So let's see, a two-way table displays the same information as a Venn diagram. So here's a Venn diagram, a survey of 80 students, and you might be like, wait a minute, 30, 16, 25, I don't know what that adds to, but it doesn't add to 80 because there's 9 students who didn't answer either of the questions in the circles affirmatively, and so they were in neither category. They were on the outside of the circles. But if I add up all 4 of those numbers, theoretically, that should be 80. So let's see if I can take this information and turn it into a two-way table. And so this cell here would be students who speak a foreign language, and this is and logic as far as the overlap in a single cell, and play an instrument. And so speaking a foreign language and playing an instrument, oh, that's the easy one. That's 16. Okay. What about speak a foreign language and does not play a foreign language, play an instrument? So that would be this region, right? That would be the 30 students right there. And then the total number of students that play an instrument, well, that would be this whole circle. That would be 30 plus 16, or in this case, that's the 16 and 30. This whole row added across would equal 46 of the 80 students. How about students who do not speak a foreign language? Ooh. All right. Now, actually, which way could make more sense? All right. Actually, let me work it in this column. There's a few ways I could do that. I could have calculated that this way, but I'm going to read it this way. How many students play an instrument and do not speak a foreign language? The negative there, for some reason, makes it harder to read first for me. Don't know why. So students who play an instrument and do not speak a foreign language are going to be these students right here, the 25 right there. Students who do not play an instrument and do not speak a foreign language, neither, who don't do any of those things would be outside both circles at the same time, and that would be the 9 students here. Now, the total students who don't speak a foreign language would have been everybody that wasn't in this circle. Now, total foreign language speaking students was 46. There's one way I could do it. Since the total was 80, I could do 80 minus 46 and get 34. I also could just add across this row the non-foreign language speakers added together. Also happens to be 34. And haha, this is another valuable total to be aware of. Notice this column. If I total this entire column, 46 and 34 do add up to 80 that way. That's good. And I've got to get totals across the bottom here as well. And so 16 and 25, 35, 41. If I add those together, and 30 plus 9 is 39. And then, let's verify 41 plus 39 going across also equals 80. And so now that I've organized that information, let's see if I can answer the question. How many students play an instrument? Play an instrument would be the entire column, right? And so that's the 41. Boom. How many students speak a foreign language? Speak a foreign language. That would be going across. That's the 46. How many students play an instrument and speak a foreign language was the 16. How many students do not play instrument and do not speak foreign language was the 9. And then how many students play an instrument and do not speak a foreign language? So play instrument, not, boom, right there, 25. All right, so that's kind of how you generate these tables. And then you can use these tables to generate even other tables that reflect the probability of randomly selecting a student that would land in either of those categories. And I guess let's explore the probability piece real quick. We'll just do part A, and then I'll jump into the examples, which I think I'm only doing a couple today and probably some monitoring progress. We'll see. And so the probability of randomly selecting a student of 80, so the total space that I'm looking at, the number of possible outcomes, is randomly picking one of 80 students. Okay, and so for probability, the denominator would be 80. Now, success in this case is picking a student who plays an instrument, which would include either both of these or would be just this. Okay, and so there's two ways I could have come across that conclusion. I'm gonna do just the bottom here. Boop, boop, boop. So just 41. Up in the Venn diagram, I would have been able to generate that probability. Student that plays an instrument would have been, these two would have been my successful outcomes, and all 80 students, right, would have been my possible outcomes. Okay, and so to calculate that probability, I've got a little handy dandy calculator. It looks like it's a little more than 50%. I'm getting 51.25% con mis calculadora. All right, so that's the general idea. So making a two-way table is a frequency table, so it tells you how often students land in one of those categories, if we're talking about students. And it displays the data in these rows. The value in that individual cell is called the joint frequency. Joint as in they're joining both of those together. It's an and logic. So a student who is a freshman and is attending is the logic that's taking place. It's each entry in the table is called a joint frequency. The sums of the rows and columns are called marginal frequencies. And so over here, this is the margin, right? Or over here was the margin. And so I think about margins on a sheet of paper, sort of thing like that. So margins will be on the sides or on the bottom in this case. Okay? So there's no marginal totals represented here, no marginal frequencies in that particular problem. So let's jump into example 1. Okay. All right. In another survey similar to the one above, 106 juniors and 114 seniors respond. Okay, so where could I put 106? Well, that includes juniors who were both attending and not attending. And so that would be the total number of juniors. 114 seniors respond. And so the total number of seniors is here. It looks like I could possibly add those together right now, which I'm getting 220 if I add those all up. So I already know the total number of students that were asked. Let's see. Of those, 42 juniors and 77 seniors plan on attending. So they're giving me kind of the attending only information. So 42 juniors and 77 seniors. Okay, and so now, I've got 2 out of 3 in this column, so I could find the total by adding those together, and that's 119. And looking across, now wait, let me finish reading the problem. Organize these results in a two-way table, then find and interpret the marginal frequencies. Okay. All right. So they didn't give me any more facts, but notice this. I was able to figure out this by adding those two. I could figure out the total by adding the two joint frequencies. Now here I know the total, and I know a single joint frequency. Therefore, I know that 42 plus whatever would equal 106. Another way I could figure out this whatever is, with algebra, subtract 42 from both sides, or just do the 106 take away 42. And I would get 64 non-attending juniors. And so this is kind of like a binary choice that we had here, right? They were either attending or not attending. They couldn't do something in between. It's not a possibility. And so to figure this out, between 77 and 114, I'm not adding them, I'm subtracting 77 from 114 to figure out who remained, who were the non-attending students, and in this case that's 37. And this cell, now I've got two options. I could have added the column this way, or I could have taken 119 away from 220, and I would get 101 is the possibility. All right, and so I've got the marginal already figured out. Boom. As far as then find and interpret. So 119. Oh, that's a valuable piece of information. What are we even attending? I don't even know. What are we attending? Something. They're attending something. School concert. Boom. All right. So this piece of information is good to know like how many people are in the audience. Knowing the number of people not attending probably doesn't matter too much as far as your show goes, unless you're gonna suddenly start throwing a whole lot of money at an advertising campaign, right? Sell ice cream, give ice cream cones to people, right? You don't want to give more than the total number of students. I don't know, maybe that would be persuasive if everyone gets a whole lot of ice cream. Who knows? But anyway, so that's kind of how that information works. Here's monitoring progress 1, and I'm taking my time on these because I think it takes a little while to get used to the setup of these. You randomly survey students about whether they are in favor of planting a community garden. Of 96 boys surveyed, so that's a total, right? 61 are in favor. Okay, very good. Then of 88 girls surveyed, nope, Mr. Waddy. The total number of girls was 88. And 17 are against, so 17 girl against. Boom. Now, I could figure out the total number of students. Did they tell us that? No. But if I add those together, we'd have 184. Now, let's see what I can figure out. To figure out the number of boys against, I would do 96 minus 61 and get 35. To figure out the number of girls in favor, I would have to do 88 minus 17, which happens to be 71. And now I can just total. 132 is the total number of students in favor. Okay. And as far as like thinking probabilities, I could look at, 132 out of 184 students. That might be a valuable piece of information for me to know. And those against, there's two ways I could do it. I could add up the number of against, or I could work with the row and do 132 subtracted from 184, and I get 52. I'm not a fan of meh. There we go. Well, I don't know. Meh. All right, and so now I know the total number of girls that were asked, the total number of boys, the total in favor, total against, total number of students who were, right, from both categories. It's all good. And so, yeah, so filling these out, it's kind of like, right, filling in the information, it's kind of a fun little puzzle. All right, now, don't freak out about this. This is there's a lot of vocabulary going on here. But not only can I find the frequencies, the number of students, for instance, that land in a given category, I can also find their relative frequencies. I'm going to relate it to often the total number of values, okay? And so instead of displaying a frequency, I can display relative frequencies, which are going to be kind of like a probability is what it's going to end up being. It's going to be a decimal value. Or I guess you could leave it as a fraction, but no, they're always decimals. So relative and conditional frequencies, and today we're going to work with, I believe, just the top two. So joint relative frequency is the ratio of a frequency that is not in the total row or the total column to the total number of values of observations. So what we're going to give this a try. Don't you worry. Let's see. Actually, let's do that first. So example 2. Find the joint relative frequency. So I'm just going to do that one piece. Okay. So use the survey results in example 1. Here's, by the way, the answer from example 1. Already copied and pasted here. Bunch of little facts for us. Wonderful. Wonderful. Okay. Use the results from example 1 to find the joint and marginal frequencies. And so, in order to do this, there we are. These, like I said, are going to behave like probabilities. And so for these joint frequencies, the denominator of the probabilities are all 220. Oh, I've got to give myself a little bit of space. So 220, 220. All right, so the total possible outcomes was 220 in all of these cases. And the successes. So if I want, I'm basically going to be writing here, what's the probability of a student being picked at random that was a junior who is attending? And so what I would have considered a success here would have been the 42. And if I simplify that, I would get, I really want to write this as a percent, but I guess 0.191. So 19.1%. is the way that works. By the way, if you didn't have the total represented there, if you just had the 4-part two-way table, you also would have 220 represented here. All 4 of these numbers should add up to 220 as well. And so it's the part divided by the total. I'm finding the joint relative frequency. Joint because I'm combining those who are juniors and attending, joining those two things, and logic, and then dividing by the total number. And it's so relative to the total population or data set. Okay? And so over here, for number of juniors not attending, there were 64. Here was the 77. And here was the 37. So if I calculate those things, I get 0.291. Here I would get 77 divided by 220 is 0.35. And here I get approximately 0.168. Okay? And so so these behave like probabilities, right? So 16.8% of the students were seniors who were not attending. Or if I randomly pick a student, right, what's the probability that they were a senior who wasn't attending? Was 16.8%. Okay? And so let's see, what's the next piece? The marginal relative frequency. Well, I already know what a marginal frequency is. That's my totals, the things in the margins, right, the things on the side. And so marginal relative frequency is the, well, there's a couple ways I could do it. I could actually just add the joint relative frequencies in a row or column. And that might be the easier way to do it. But I might define it both ways for us in a second here. So if I just do 0.191 plus 0.291, I should get 0.482. Okay, and so this is the marginal relative frequency. Okay, it's in the margin, and it's saying basically 48.2% of all the students were juniors. Okay, and so this is the way that the book suggests finding it is, hey, add up those things you just found. Theoretically, I also could have found it by doing 106 divided by the 220, right? So the 106 there divided by 220. And let's see, that should, I'm going to punch it in a calculator. And I get, 0.4818, which rounds to 0.482. All right, and so there's 2 ways you can find it. So let's see, this one I would have added across. You get 0.518. Now, notice if I add this column, what's the total number of students? What percent of them were polled? Well, what percent of the students polled are in the survey, right? All of them. All of the ones I polled are the ones that I polled. it's a 100%. And so if I add up 0.482 with 0.518, I get 1.00, right? Which you could think about as 100%. You could just write that as 1. And so to find these, I could add the columns. I get 0.541. And if I add these columns, I get 0.459. And theoretically, verify, if I add across, it does in fact equal 1. And if I wanted to, let's say I was finding the total number of students not attending, well, I could have taken this 101 and divided by the 220. And if I did write 101 divided by 220, let's just check this system. And this is valuable. It's worth doing. The more connections I can give my brain with a new concept, the greater the likelihood I'm going to remember it. And I get 0.4590. Boom! Got him. We're doing it. We're doing it. Okay, let's look at the monitoring progress question. You might be good to roll on your own, but here we go. This was use the survey results from monitoring progress question 1. We had hopefully generated that very same. Did we? Doodly doodly. All right, so use those results to make a two-way table showing the joint relative frequencies and the marginal relative frequencies. All right, and so the total possible ways is 184. I could find that there, or I could find that if I added all those. But why would I do my job twice? Right? So I would do divide by 184, divide by 184. That's the total possible outcomes. That was the number of people surveyed. There were, what was this, about like the community garden? Something is what it was. Now, as far as number of successes, boys that were in favor was 61. And so I would write the 61 right there. And if I do 61 divided by 184, I get 0.332. And I'm having to write so tiny. I should have made this bigger. That's okay. All right, and so here would be the 35. Here would be the 17. Here would be the 71. All right, and so I get 0.19. I get 0.9092. Whoa. Yep. And here, if we do 71 divided by 184, you would get 0.386. And so you could say that 38.6% of the students polled were girls who were in favor. Boom. All right. And so, so to find the marginal relative frequencies, margin, remember, in the sides, in the margin, I just add them up. And so this is going to be, what? Oh, 0.718. So 71.8% in favor. That's worth communicating. That's a good data point. 0.282 if I add this column. And if I add across, boom, got them 1. And add the row, 0.522. So more of the survey takers happen to be boys than girls in this case. And 0.478. All right, so yeah, there were fewer girls than boys that were surveyed. Although a majority in both cases, right? 33 compared to the against, right? Yeah. Both cases ended up being in favor, so it didn't dramatically swing things. So anyways, thanks for watching, internet friends. You should be good to go based on what the homework is going to be tonight. Take care. Bye-bye.